Okay, in this video I'm going to do an example where we do an attenuation problem, and attenuation is measured in decibels per kilometer as given here, and the idea here is that if we multiply the attenuation times the distance, we're going to get a loss value in decibels. And so the equation that we're using here is that the loss in decibels is equal to the attenuation times distance. Okay, so the dB of loss is dB per kilometer times kilometers. Okay, and now it asks us for the maximum distance of a fiber transmission cable if the maximum loss is 25 dB. So you can see here that the loss is proportional to the distance. So if I have a maximum loss for a given attenuation, I'm going to have a maximum distance. So basically I'm going to solve this equation for D, and I get D is equal to L in dB over A. And if you want, I could call this D max and this L dB max. And I'm going to have 25 over 0.5 or a maximum of 50 kilometers. Okay, and this is a typical loss for optical fiber. Very low losses typically, so we can go a 50 kilometer run and still have just 25 dB loss. Okay, part B. So the problem solving technique here is to write down what I've got. The attenuation is 0.5 dB per kilometer. The loss is 25 dB. Write down the relevant equations, solve for the unknown, and plug the values in. Okay, for part B, we'll do the loss budget. A laser signal with optical power 10 milliwatts is launched into a 2.5 kilometer piece of this fiber. What is the optical power of the signal that emerges from the fiber? Give your answer in milliwatt units. Okay, so the equation we're going to use here, so what we've got is P in, we're given P in dBm, we're given P in milliwatts actually, so let's go ahead and convert it into dBm. P in milliwatts is 10 milliwatts, and P in dBm is 10 log base 10 of 10 milliwatts over 1 milliwatt, and this is 10 dBm. 10 is 10, whether it's milliwatts or dBm. Okay, and we're given that the it's a 2.5 kilometer piece, so D is 2.5 kilometers, and we're asked to find P out. And so P out, the equation I'm going to use is P in minus L. And this is all in decibel units, so this is P in minus AD. And we're given Pn and A and D. A is given above, it says this fiber. 2.5 kilometer piece of this fiber, and this piece of fiber has 0.5 dB per kilometer. And so this is all in decibel units, and P in is 10 dBm minus 0.5 times 2.5. And so it's 10 minus 1.25 or 8.75 dBm. Half of 2.5 is 1.25. 10 minus 1.25 is 8.75. Oh, and they want it in milliwatt units. Okay, so P out in milliwatts is 10 raised to the P out dBm over 10, which is 10 to the 8.75 over 10, which on my calculator gives me 10 raised to the 8.75 equals 0.875. 10 raised to the 0.875 is equal to 7.499 or 7.5 milliwatts. Okay, so we put how much in? 10 milliwatts, and we got out 7.5 milliwatts. Okay, so here's an example of loss budgeting with an attenuation, and it also has a maximum loss calculation here, a maximum distance for the allowable maximum loss calculation in Part A. Okay, hope this helps.